All right, so let's get started. We will start with C++ programming. And well, I know only so much, and whatever I know, I'll share with you. I didn't do much programming in C++. Most of the programming I did is in C. Later on, I tried to learn, but I didn't. I learned a bit, but what happened? I didn't write large programs in C++. So my experience is less. Okay. In any case, well, see, these days I use Python because whenever I want to do something, I want to do quickly, fast. And so Python is, I can do things very fast. But you should C++, and I'm learning Scala. You should all learn Scala. Yeah, so Scala, S-C-A-L-A, Scala. Yep. I'm trying to learn Scala. It's a functional programming language. So C++ programming language, sure, just give me a minute. So C++ programming, it is useful for a software design design and development methodology called as object-oriented design and development. So, you know, like when C programming language was designed way back in 1970s by Kernighan and Ritchie, their goal is to design a language which is very versatile and which is very close to the machine. So you can see the number of the features of of C programming language, they are very less. The number of building blocks are very less. And everything is built around it. Okay, but you can do pretty much anything using those building blocks. And also it is used for systems programming if you want to if you want to build an operating system kernel, or if you want to build an embedded system software, very low level things you will be able to do with C programming language. And if you, so because of that, in C programming language, the checks and balances from the compiler are very limited. The compiler doesn't you know, force. You can override the compiler and get your way. The compiler at best may give a warning and let you go. Okay, this is what it is. No, if don't blame me if something goes wrong. It wants you and lets you go. Because the reason is when we go and work at the assembly, when we try to program our systems, machines using C programming language, all these things are required. Like, you know, like for example, for a pointer, we never use, we don't explicitly say, no, if there is a program, we all the time car pointer, we either use an malloc or something like that. But in C, you know, you can kind of say, I want PTR to contain this address. Okay. But then, so and then the way we think about programs, build large software in C, is our whole software is divided into multiple files, and every file is a collection of functions. So it is a modular development of the architectural approach that we use is modular development, modular program development. So there is a big task that we have to do. We divide it into subtasks, maybe divide it into 3 tasks. And so like each of the task is again subdivided into multiple tasks. So one team A may work on this task, team B may work on this task, and team C may work on this task. So we split the whole software development process into, we look at our software or our system as a collection of modules. And every module is divided into sub-modules. And finally, if you keep going like this, if you keep splitting, finally, if you see at the end, you will see small functions. This is a function, this is a function, like small functions. This is the place where you do write the code. And we have seen, we try to manage, we try to kind of bring some structure and sanity to this complex software development process by using macros. Okay, you use macros. So like, for example, if you are using some value of pi, the same value of pi should be used by all the teams. It cannot be the case team A uses some value for pi and team B uses some other value and team C something else. So we use macros is one. Number 2, like for example, we use build systems such as makefiles. And then of course, version control system, Git, etc. And then debugging approaches, assertions. So those things again we use to see that that we go about developing our software in a systematic fashion. Version control system, we will I will send you one link. You can watch that video. But essentially, like when you are developing a program, you have a working version, and then you want to include a new feature in your program. So you have initial version, like what did we do? We have, like for example, sort1.c. In sort1.c, we use some sorting thing, and then sort2.c. Like that, we have different versions, and we keep track of the version by giving them numbers, but this doesn't quite scale when you are working on a large software. So we use what is called as a version control system to manage different versions of the code that you have. You should learn it sooner before you go to next semester. You should learn how to use Git. And when you do development, code development for data structures course, you should use Git. So I have it done. So Chirag says there is a session on Git. Yeah, good, very good. Nice. But then the features C lets you do many things. It doesn't kind of it wants you, but it doesn't force you to do things in a certain way. So like for example, maybe if you use something like this, C may warn you, but it lets you do whatever you want to do. Again, as I said, it is required for the purpose for which C programming language is designed. So all these things serves well. All these things serves well for that towards that purpose. But later on, people started using C programming language not only for system software development like kernels, etc., For other software also, people started using C. And when we use C programming language for general software development, then a bunch of challenges will come in. For example, modular software development is not, it is okay, but it is not good because, there is a namespace pollution. The variables that you are using in one file, you may end up using in another file. Lots of challenges you will face. Scope, scoping rules, and all these things will introduce bugs in your program. Okay, not in small programs, but in big programs. Okay, I don't even call them programs in developing. When we develop software, that is, which typically have at least 20,000, 30,000, 1 lakh lines or million lines of code, C wouldn't work well. So people came up with an approach called as object-oriented design and development. In object-oriented design, your whole system, you think of it as a collection of objects. And these objects interact with each other through well-defined interfaces called as methods. So, like for example, you can have, like if you're thinking of a game, so like for example, FIFA 2020 game, video game, then like for example, you can have an object. Your game is a collection of objects, and there are some objects which are of type players, and there could be some objects which are of type referees. There could be some objects which are of type commentators. And let's say if you take the player object, say Messi could be an example of a player object, and he will have a bunch of attributes, and there are methods through which you can control Messi. Okay, so similarly, every player is represented using these. Yeah. So, who is the latest player you want to keep? Any favorites? Ronaldo, Chetri. Okay, Sunil Chetri. Why not? Neymar, Harry Kane. Okay. So yeah, so anyway, so all these, so your system, your FIFA game, it's a collection of objects, and all these objects, they talk to each other through these methods. Okay, you cannot go and slap Messi, slide if you want. Let's say if you want to not slap Messi, you cannot foul Messi. If you want to foul Messi, you have to go call a foul method through which you can foul Messi. Okay. So we'll try to understand this through examples. So this is a way of design and development, and C++ programming language supports this. C++ programming language supports this object-oriented design and development. So object-oriented design So I strongly suggest all of you to invest time, in the data structures course. Just write every program in this fashion only, because you need to. We will see, Akshit. Okay, so here what happens is the data and the methods which act on the data, they are encapsulation. Okay, so through examples, we will understand these ideas, but there is a general software design development strategy, which is called as object-oriented design and development. And then we use C++. C++ is a programming language which supports this design and development strategy. So is Java, and so is Scala also supports object-oriented design and development, because Scala is an extension of Java. And Scala is not only object-oriented, it is also functional programming language. Okay. we will see. You will learn about functional programming later. But for that, so while we talk about functional programming language, so there is one video on how to do object-oriented design and development using C programming language. I gave that lecture sometime for the last year batch, but it pretty much went over everyone's head. So this time I will just point you to that video. So those of you who would like to watch, you can watch it. Okay. Okay, I will send the link. Okay. So what else? So the other thing is the C++ programming language. C++ is a subset of C. Is a subset of C. So everything that you can do in C, you can do in C++ pretty much. So that means using C++, you can do both modular software development or superset. Awesome. Thank you, Doravik. So everything that you can do in C, you can do in C++. So that means you can do modular software development in C++ also. And you can do object-oriented design and development also. Both modular structured software development and object-oriented design and development you can do in C++ programming language. All right. Okay, so now let's initially, so C++ programming language, it is written by, you will see Patanjali, it is not, we will see through an example. In an abstract way, how much ever I explain, it doesn't make sense for you. So you only get some level of intuition, but when I make it concrete through example code, then you will appreciate it. Okay. You will, in the next class, you will see that. So C++ is developed by Bjarne Stroustrup. And interestingly, the initial compiler for C++ programs, like for example, they have the extension CPP. The initial C++ compiler is very interesting. It translates a C++ program into a C program, and the C program is translated into your executable A. So this is what is called as a source-to-source translator. Source-to-source translator. All right. So your C++ program is transformed into C. They can be, but the first compiler that is built right now, the compilers, the current compilers, they generate A. They don't generate C. But the first compiler, this is true of the first compiler written by Stroustrup. It takes a C++ program and generates a C program. All right. Recent compilers, they translate C++ directly to assembly code. Okay. So now let's try to write our first program, hello.cpp. I'm using .cpp as an extension. You can see here .cpp indicates it's a C++ program. So yes, so just like we use stdio.h, in C++ we have what is called as an IO string. You have what is called as an IO string. And you can see there is no .h here. In C++, in C we have this .h extension for header files, right? it is a convention that we use. Even if you don't have .h also, the include still works, but that's a convention that we use. But in C++, we no longer use .h is not required. We just say include IO string. So next, we have the main function, just like C, and then we return 0, int, this is the string. And in C, we use printf and we use printf, right? So in C++, we use what is called as a cout. Hello world. Okay. So cout is a stream. Let's compile this program. So cout, this is the way, just like printf, this less than it's a shift operator. This less than is a shift operator. But what happens is in C++, this less than, it is overloaded. The semantics of this operator depends on the type of the parameters being passed, the type of the operands to this operator. Okay, like like in C, in C, what do we do? So so this is some val is less than 10 means you shift the variable val to the left by 10 bits, where val is an integer, But here in C++, the shift operator, we will see what is called as an operator overloading. We will see in C++, is operator, this shift is overloaded, less than is overloaded. We will see what overloading means for a period of time, but in C also we have operator overloading. We will talk about it in a moment. But on line number 6, what you are seeing on line number 6, it is supposed to print hello world onto the screen. And let's compile this code. How do you compile C++ code? So G++ hello.cpp. Where is this one? Oh, it is in 21, CP21AB. Yeah, so this is what some of you are all, are unhappy about me that cout was not declared in this scope. So in the standard input-output stream, this cout stream, it is defined in what is in a scope in a namespace called as std namespace. So namespace is an important idea in C++. All the things, that all the libraries that you build or functions that you build, you can enclose the scope of whatever the things that you are defining within what is called as a namespace. So std is what is called as a standard namespace. Remember this keyword, this count. This is not count, cout. Cout is not a variable. It is a variable. It is a object. It's the name of an object from std namespace. So now let's compile this program. So when we use cout, earlier it gave a compilation error. It is not like stdout. This is like cout is equivalent to printf. And so it gave a compilation error saying it didn't recognize cout. But then when we specify that we are referring to the cout from the std namespace, now the compilation will go perfectly fine. See, so now it prints. Are you all with me here? Or so /n you can also use endl, endline, and so why endl is a problem? Endl is supposed to introduce a new line, so you have to explicitly use std endl. So endl is also in the std standard namespace. So when you compile now, it works. Because GCC will, let's compile GCC and see what happens. GCC only recognizes C programming language. GCC doesn't recognize the constructs from C++. Okay. So, but you can see that wherever whenever you are using something from the standard namespace, you have to keep this std double colon before that. So this is a pain. So what do we do? So we use this using namespace std, this line we use. So once we use, once we specify that that we are using std namespace, then we can remove these things and compile the program. Sorry. See, I don't know which is better, endl is better or /n is better, I don't know. Okay, can you use multiple namespaces? I think it is possible to use multiple namespaces. Both are the same, but I don't know whether which one is better, endl is better or /n is better, I don't know. Endl flushes the output buffer. Oh, okay, thank you, Bharat. You understood? Endl, oh, /n also does, na? At least in printf, when it looks at /n, it flushes that. Okay, so this is your first Hello World C++ program. All good? Did you understand the idea of namespace? Namespaces are not objects. No, namespaces are not objects. std is not an object. std is a namespace. cout is an object. Abhinav has both endl and /n serve the same purpose. However, they insert a new line. See, perhaps it may be possible cout doesn't do a flush with /n, whereas printf does. Yeah, exactly. That's what Abhinav is also doing. Okay, now let's move on. So now we write one more program. We write two interesting programs, and so one program is there are two dice, and so 6-faced dice, and we throw and we count. We sum up the values that shows up on the two dice. Are you with me here? 6 die. We throw them, and let's say you see 1 and 5. The sum of them is 6. We want to compute when we throw a dice. Or is it so? Yeah, I didn't even think about it. So when you throw a dice, then what happens? Yeah, so let's try to solve this problem here. So hash include, I think if someone didn't do it by now, we are writing this program in C. Hash include stdlib.h, hash include time.h, main, zero. So what do we do here? Hash define number of sides. Hash define throw a side. It is defined as let's see. It's the code that I yeah, so like just 1 minute. Okay, so I'm back. So we use are you able to see my screen? Rand percent sides plus 1. Okay. So now what we ask is we ask int trials, how many trials? So printf enter the number of trials. Percent trials. Okay, and then what do we do? For int j is equal to 0, j less than trials plus j, d1 is equal to, so generate a random side, and d2 is equal to r underscore side, and then we have int outcomes 13, and we want to initialize all of them to 0. This is how we initialize all of them to 0. 13, it's okay. 2 to 12, right? Yeah. So that means 11 is read. Yeah, but there is a reason why I'm using this, to make my life easy. Outcomes d1 plus d2 plus. And before we start the exercise, sran clock. Okay, now we have to use same story. Probability is equal to def. Thank you to everyone. Okay, all good. Def probability distribution slash n. So now gcc dice.c, oh, compiled, awesome. So now we do a dot out. Everything good except slash n. See, you can see I tried 10,000 trials here, 1 lakh trials. So yeah, it's making sense, right? Around 1 million trials. Okay, this is what it is. Okay, good. So here, is this the problem? Okay, anyway, so couple of things, exactly same. Huh? Okay, anyways, see, couple of things I would like you to understand here. So line number 5, we are declaring sites and we are using macros. Okay, so here we are writing code. So here we are writing, even we can replace whatever that is there. Everyone, so whatever that is there, it would be exactly replaced. Okay. Whatever, it doesn't matter what is there on the right side, it will just be replaced. It doesn't, the macro doesn't check what is there on the right side here. The C preprocessor doesn't check what is there on the right side. It just replaces it. So if you try to, it is possible to make it multiple lines, Divij. Yeah, it's possible. So well, the issues are when the macro processor does a simple textual substitution, because of that, when we write, the compiler will not be able to do some interesting checks. Okay, so let's try to rewrite the same code in C and see where we end up being. Okay, so in C++, let's say instead of using stdio.h, we can use iostream, and this stdlib is available as cstdlib, and time.h, any .h file from C, it is available if you put a prefix before it, and we can just remove the .h. So all the libraries that are in C, they are available in C++ also, and we just have to, while we are including, remove the .h and you put a prefix C before it. And the second thing is, instead of this hash define, so we would like to use a better way of using this is const sites6. Okay, and this is important because when you define a constant and the way we are doing on line 9, we are giving a very important information to the compiler that sides is of type integer. And compiler does lot of what is called as many errors in your program. They will be caught by the compiler by doing this type checking. And if the compiler doesn't know the type of some object, then it will not be able to capture the error at the compile time itself. And because of that, you may get very nasty errors down the lane. This is a big problem in Python, because in Python, you don't need to specify the type, and the type of the variables keeps changing as you run the program. So what happens is when things go wrong, you may just before, like for example, Mars rover is going to land on Mars, some error comes, and the compiler figures out that you are not the compiler, the runtime figures out that you are trying to add an integer to a string, and then the system will crash just before it is going to land. Okay, so we want to catch all the errors as much as you can at compile time itself. And an important part of this exercise is what is called as a static type checking, that is compile time checking. Compile time checking. And this type information, it provides information, it provides documentation to the programmer. So now we know that sites is an integer. Okay, that the site6 is an integer, we know. Okay, so that's an important thing. So now we would like to have inline int or side return. We can use hash define, but we should avoid. That's the thing about C++. It says, yeah, it's up to you, you use it, but you better know what you're doing. Okay, so now on line 10, we defined a new function called r_side. And when you call r_side, it returns a number between 1 and 6 at random. What does this inline keyword do? So whenever we call a function, there is a lot of overhead involved in function calling when we call a function, because when we call a function, what happens is certain things need to be set up. So if this is actual function code, so we will have what is called as a function prologue. It is like setting up the stage. And then there is what is called as a function epilogue. This is like dismantling the stage. So if the code that is present within the function is large, then the prologue and epilogue overheads will be small. But if the code that is present is very small, then the prologue and epilogue cost will be overheads will be high when compared to the actual code that is present. Okay, like for example, if 99% of the time is spent here and 1% here and here, then there is no problem. But if it is the case, 50% of the time is spent in the code here and 50% in prologue and epilogue, then that's going to be an issue. This problem, but at the same time, we would like to use functions so that our code looks modular, our code looks neat. Okay, so because of that reason, we want to use functions. So how do we solve this problem? So what we tell the compiler is, you know what, I am using this function r_side for modularity reasons and for code cleanliness reasons, but you attach this tag inline. What this inline means is wherever this is called, you don't call that function, but this function call is replaced with the instructions associated with that function. Okay, the instructions associated with r_side, they are replaced. Are you all with me here? The inlining, what inlining means? The instructions are replaced. Instructions are replaced. And then let's use this one, cout less than. And then now we are seeing for the first time how we read input. So this is also nice. You don't need to remember what is the format specifier for an integer. All those things you don't need to know. If you want to print a string, if you want to print an integer in C, you have to remember all those format specifiers, and that has got it's okay. We are all going through trials. Okay, so this makes it so what happens is no, inline and lambda are different. Okay. Are you with me on line 18? That how you can read input? You have to use cin greater than and the variable, and you don't need to remember any of the format specifiers. That's the story. And then we would like outcomes to be an array. Okay, so we use int outcomes. We use a keyword called as new. So this declares, this defines, this allocates a chunk of memory which is equivalent to 13 times 4, that is, which is the size of an integer, and outcomes, this is dynamic memory allocation. So the important thing was with this is equivalent to malloc that we used in C programming language. But the important thing is in malloc doesn't know the type. In malloc, what do? We just ask for a chunk of memory and we kind of do some explicit typecasting. But here, when we use malloc is library, it's not part of the core C programming language. Well, malloc is a standard library. It will be there in all wherever we use C programming language, but it is not like malloc is not a keyword. But the way dynamic memory allocation happens in C++ is by using this new keyword. Is by using this new. You call new. And then you give how much amount of memory you want. Are you with me here? This is important because you're telling the compiler the type associated with the memory that is being allocated. Okay, we are telling the compiler clearly that we need 13, an array of 13 integers. That information is being passed to the compiler, and that's an important information for the compiler. How is it different from vectors? So Abhinav, I will read about vectors today and I will tell you about it next class. So memory is allocated on heap on line 15. Yeah, that's true. It's related the same way as in C language. Okay. Yeah, we need to call not free, we need to call delete. We need to call delete. The equivalent for free in when we use new and delete, let me write here malloc and free, they work together. New and delete, they work together. A memory that is allocated through a new, you cannot use free, they don't go together, so don't use that. And of course here, what should we use? Using namespace std. All right. Yeah. So here one more thing we do, the way we static cast, we want to do the typecasting in a much more cleaner fashion in C++ by using this function called as static cast, and after that we have this angled bracket in which we are passing this double. You will see what it means, you will understand where and how this is coming in some time. Okay, but for the time being, this is a better way to do typecasting than the way we are doing it before. Okay, static cast. Okay, thank you, Abhinav. It is not compulsory, you have to use typecasting though. Okay, so it's not here. Great. So what else? Now after this whole stuff, so we want to do cout less than p what should we print? Probably j. Okay. Shall we compile this code? Line number 16, we are allocating a dynamic array. We are allocating an array dynamically, not a dynamic array. We are allocating an array of size 13 dynamically from the heap on line number 16. And the way we do it in C++ is by using the new keyword. New is a function. It's new is not a keyword. We use new to do the allocation. Are you with me? C in greater than trials, it will only read integers. Yes. Shall we compile the code? G++ dice.cpp. Okay, so this is how it looks. Make sense? Are you all with me here? The important in this one, We just did cout. No, we wanted to print a p of p left parenthesis, followed by that we want to print j. So you just look at the cout a bit more carefully. That's all. I did not use delete because we are exiting from the program. So the two important things I would like you to understand here is it is better to avoid macros and use the way we defined this variable size. We mentioned it as a constant and we declared its type. Similarly, on line 11, we are telling that r underscore side, this is the body of the function and it returns an integer, and please inline it. So this is a much more cleaner way of writing code than using macros that as we do in C. Are you all right with this one? These are the two important observations from this code. How do I print the answer to some decimal like we do? So check, Aman, that's a homework for you, how we do it. I don't know how you can do it. You please check. Good question. We can use printf. Okay. The actual cool stuff comes in the next program. Would you like me to continue 10 more minutes, 3:15? This is very, very powerful what you see after that. Okay. So you recall swap.c. Oh, cancel. Okay. Let's see, there is a program swap.c already present. Huh. So remember this program, swap.c. So here, when we want to swap two integers, this is the code that we have. But let's say if you want to swap two doubles, okay, two variables which are of type double. So we have to write one more function. This is swap int. And we have to write one more function, swap double. We can delete this code. And does this make sense? That if you want to swap two doubles, that we have to write code like this. And let's say this is double dvar a. Okay. So I will use, for the sake of simply, yeah, this is and before printf, before swap, dvar a is %f, dvar b, %f, dvar after swap. So LF, in this case it may, okay. Shall we compile this code and see if it works? Oh, I have to call swap int. called swap int and swap double. It's all good. You're all happy? Let's compile this code. G++ swap.c dot a dot out. Oh, it's okay. You can compile a C program with G++ also. So you can see it is working, right? Did it got swapped? No, it is looking the same. Oh, I printed on the opposite direction. Brilliant. So some of you guys this is what you were asking me at the beginning of the course. For some problem, I think. Can we print swap two variables means can we print them in the opposite order? Okay. Transpose a matrix, print the matrix in transpose. Topple a car, okay, look the other way like this. And the car looks toppled. Smash a building, smash your brain. It looks, the building looks smashed. Okay, I'm sorry guys, I'm just pulling your leg. Okay, all good. So now we want to write this code in C++. Swap.cpp. Okay. So for the sake of simplicity, for the sake of time, I will just use stdio.h and printfs, okay, and change the other things. So when you are working in C++, like we don't need to use, let's look at swap int, okay. So we can use in C++ provides what is called as a pass by reference mechanism. So we can use this particular way of declaration here, declaring the parameter. Then what it means is, and then here, so similarly here, we can have the same name, but these two functions, the function on line 3 and the function on line 12, they are different from each other because their parameter types are different. The first difference I would like you to observe is line number 3, there are two function definitions with the same name, but their signatures are different. Are you with me here? First difference. Two functions with the same name, but the parameter types are different. The second difference is the parameter. So that means on line number 29, we don't call swap int, we just call swap. And yeah. And then the second thing that we do is we are passing variables by reference. So we don't pass address. We just use the variables as parameters as it is. But whatever the changes that whenever you refer A here, like for example, on line 29, when you call swap with var A and var B, wherever you use A, you are reading from var A. And when you are updating, here on line number 8, when you are updating A, then var A is getting updated. Are you with me? This is like true call by reference. And this is not there in C++, in C. So we are using call by reference parameter passing mechanism. So we no longer require pointers. So any update to A, it gets reflected in the parameter dvar A. Any update to B, it gets reflected in the parameter dvar B. Are you all with me here? How we are using call by reference parameter passing mechanism? Okay. So whenever you want to use a call by parameter passing mechanism, you have to use this thing. Okay, this ampersand symbol. If you remove this, then it is call by value. Are you with me? If you remove this, this is call by value. If you put this, this is also call by value. When you put star also, it is call by value, guys. It's just that you are passing the address instead of variable itself. Are you all with me here? So we have to use double this. So now let's compile this program and see what happens. G++ swap.cpp. So this is the cool part, I would say. See the variables got swapped. 10, 20, 20, 10. All good? Happy? This is most important thing. Most I cannot emphasize enough. This is the first time you are looking at parameter call by reference. Call by reference. And the compiler figures out how to implement this call by reference. The compiler figures out how to implement this call by reference. Are you happy with this code, or is there something bothering you? This is also called. Is there something bothering you? Sending pointers is call by value. It's just that you're passing pointers is just pointers is value only, except that you pass addresses. No, this is not address. Okay, the problem with this code is that on line we have two codes which are exactly equivalent to each other, but we have to replicate the code because their types are different. Are you with me here? Do you see the problem? The swap function from on line 4 and the swap function on line 13, both are the same. But we have to replicate this code, which is a pain. So what do we do? What do we do? Templates, yep, or generics as they call. So we say, so now comes the template. We say that, hey, we are working with a metadata type called as T, and then that's it. You don't need to do anything. Your story is over. Okay. So now you compile this program. What is the problem? T. No semicolon. No semicolon will be there. Line 1. No, that's not the problem. Templates don't have semicolon. Oh, okay. Swap. Semicolon. Error unexpected semicolon. Thank you. Someone, Bharat. Thank you, Bharat. That's it. So now the same swap function, when you call swap with two integer variables, the compiler will generate an integer version of the swap function. And when you call it with double, the compiler will automatically generate a double version of the swap function. You don't need to do anything for it. No, this is a parameter type. There is no real class. This is the T is like in algebra. Let T be the data type of A. Let T be the data type of B. Let T be the data type of temp. And this is how the whole story works. Are you all with me on this one? This is what we have learned today. This is what is called as a generics. So when you go to C++, this is an extremely powerful way. This is what is called as a generics and templates, and then we also learned here overloading. So we learned overloading because the same function, it has there are two different functions with the same, there are the same function swap. There are two versions, and which version is invoked depends upon the data type of that function here. Are you with me here? Do you see what happened here? How the program evolved? Where did we start? In C, we have swap int and swap double. Are you with me? Just check. So we have swap int and swap double, and the parameters are passed using call by value parameter passing mechanism. We are simulating call by reference by passing addresses. Are you all with me here? In C, we defined two functions, swap int and swap double, and the parameter passing mechanism is call by value. We are simulating call by reference. We are simulating call by reference by passing the addresses. Okay. So now then we came to the C++ code, and we did two things. We removed swap underscore int and swap underscore double, we changed, and we just used swap, and we are able to accomplish it by this feature provided by C++ called as overloading, function overloading. Specifically, what we are having is called as function overloading. This is one, and then the parameter are passed right now in a truly call by reference mechanism. Okay, are you all with me here? Function overloading and call by reference. This is one, this is two, and then we felt, you know what, we are just copying the same code again and again. Why can't we write generics code? No, int this only means we are passing the parameter by call by reference mechanism. Call by reference mechanism means any change when you call this, for example, with wherever, like for example, swap with var a, var b, any modification to var a, any modification to a will be reflected in the memory associated with var a. Does it make sense? Any memory, any modification to a. So like for example, this is the memory associated with var a. Now in this function, we can reference the same memory by another name. This is called as alias. Like you are given a new name. It is like this. Okay, if you punch a here, var a will feel the punch. Okay. So too much punching. Okay. What to do? Only punches will explain. So shall we conclude today's lecture here? Do you understood generics and templates, the final version of the code? All good, happy, excited? Now, can you go and modify one of your programs? Because like, for example, when you did sorting code, you would have written for integers or double, right? So can you change your sorting code so that it can handle both integers and double? Or can you write a code which computes the sum of first n numbers? Not first sum of n numbers, no, sum of the elements in an array or something like that. So that the same function can handle both integers and float and whatever. At least I want you to take one of the code that you have written and then translate that code and apply this approach. Can you do that? Yes, no? Give it a shot. Take one of the sorting code and give it a try. Okay. So I will stop here. And so